Sister and brother surfers of the binary notion. What's up? In this video, we're going to do our if-else and our if-then, and then we're done with our control flow. So let's go into our if-else function, and hopefully I'm explaining this stuff all right. This is very complicated, at least to my mind. I'm not the smartest person in the world, but I'm also not the dumbest, so I don't think, anyway. I'm trying to explain it as best as I can, and it's just complicated. So if you have any questions, feel free to ask. I'm happy to discuss it. And I hope I'm explaining everything okay, but I'm sure I'm probably missing something. So anyway, with our else, let's go in. If else, we want to set up a variable. Current nest is readable, Boolean. Variable parent nest is readable, Boolean. So with our else, now with our if, all we had to do was check the current nest, whichever, if it was in a nest, we just checked the condition of that nest that it was in. Now with an else, we have to check sometimes with an else, we have to check not only the nest that it's in, but also the parent nest. And we'll see why here in a little bit. So if control flow stack dot count is greater than 0, then it better be, right? If we're in an else, there better have been an if. Otherwise, we want to throw an error, and we will here with the else. Okay, so if it's greater than 0, if let x equals control flow stack dot last, the top value on the control flow stack, current nest is readable equals x. If current nest is readable, and notice this is a little bit different than how I did it up above here. I put this outside of this control flow stack optional unwrapping, but in here I'm just doing it there. You can do it either way, really. So yeah, if current nest is readable, then if it's readable, then everything from else to then is not readable, right? So if that if condition was true, then as soon as we get to that else, everything from else until the end of that if condition, that then, we don't want to read any of that. So if current nest is readable, if x equals true, then control flow stack dot remove last and control flow stack dot append false. Okay. So if it's readable, I think I did this wrong. I'm going to leave it for now because it's not, I don't think it's going to hurt anything, but I'll show you what I did actually just to show you. Control flow stack dot remove last, control flow stack dot append, and you might have already caught it here. So if the current nest is readable is true, is going to be the same thing as if x equals true. So if it is readable, so if the if condition is true, then we want to flip it once we hit else, when we're in our else function. Once we hit that else, we want to flip it to false. We don't want to append another one because we only want the right amount of ifs on our control flow stack so that we can keep track of which if we're in, which if nest we're in. So instead of appending one on there, we're just going to flip whichever one's on there to so that it'll just be false. This else will never happen because if current nest is readable is the same as if x equals true. So yeah, this else would just never ever happen. But we do cover that down here. So if current nest is readable, else, and this would be this else basically, if control flow stack dot count is greater than 1, let second to last equal control flow stack dot count minus 2. So this gets the second to the last value in the control flow stack because we have to check the parent value here if the current nest is not readable. So if this else matches with, if the condition of that if was false, then we need to check the condition of that if's parent. Because if that if was set to false because its parent was false, then we still need to be false. But if that if was set to false because its parent was true, then we need to set our else to true. Because if the parent was false, that means we haven't yet reached an else matching that parent if. So everything from that if to that parent's matching else would need to be false. So this is within that, so it would have to be false. Okay, if control flow stack second to last is true, right? Then parent nest is readable equals true. So that's just saying, that's just setting the second last value to the parent nest is readable value. Okay. Else parent nest is readable equals false. And let's add if parent nest is readable. So if it is true, like I said, then we want our control flow stack. We want to remove the top value and then append. So we're doing that flip-flop. Control flow stack dot append true. Okay, so else if the parent is not readable, then we don't do anything. We're not going to toggle anything. We're just going to leave it as false because it should be false because we haven't reached that outer else yet in that parent if. All right, so then on our if control flow stack dot count is greater than 1 condition here, we want to put an else. And so if the control flow stack is not greater than 1, then we aren't going to have a parent to look at. So we're just going to do control flow stack dot remove last, and we're just going to append true, because that means if it's not greater than 1, that means we're in our first if, and if that if was false, then the else that matches that would be true. And then let's go down a couple here, and this is to our if let x equal control flow dot last, and on that we want an else, and we want to put an error here, print error unable to read last value on control flow stack. And that's just catching this optional unwrapping. If for some reason that optional can't get unwrapped, then it's almost never going to counter that error, I wouldn't think. If we do, then we'll just return. We'll just jump out of the function. And then we'll just do one more else here to catch just the very rare occasion of an error here. Error, no value on control flow stack. Else, this one would be less rare, I guess, huh? Else should be preceded by if. And then we'll just return from the function. So that's if control flow stack is not greater than 0. So if there's nothing on the control flow stack, there needs to be, because if is what puts something on the control flow stack. All right, let's with our if then function, this is a simple one. If control flow stack dot count is greater than 0, then control flow stack dot remove last. That's it. Else print. This is similar to this error here. Error control flow stack is empty, then should be preceded by if or else. And then we just do a return. Probably don't really need a return there, but have it there anyway. So if the then, if we hit a then we're going to remove the last value on the control flow stack, and that gets us out of that nested if or that final if. So that's it. That's our logic for our if else control flow. I think I've hopefully simplified it as much as possible. If you have any other suggestions or anything, I'd love to hear them in comments. Let's run our program and let's do a test here. Let's see, I have a whole bunch of tests. So let's do we'll do Bob. And our Bob function is getting more complex here. So let's go 0 if 10, else 30, then else 40, then, I don't know. Just do some weird nesting and stuff. Okay, so let's see, what should we get here? We'll get 0 on the stack, and then the if's going to look at that and evaluate that to false. So since it's false, it should skip this 0, skip this if, skip this 10, until it hits its matching else, which is not this one either, or this one, or this one. See, these match each other. This if matches with this else, so it should just not read anything until this else, and then it should read this 40, so we should get 40 on the stack. Let's see what happens when we run Bob. 40 on the stack. There it is. So, you know, feel free to get this program off my GitHub page and run it just like this, and you can do all the testing you want and analysis and see what you come up with. In the next video, we will look at doing some looping. So hopefully it's not as tough on my brain as this if else then was, but yeah, we'll be all right. Thanks for watching. Peace out.